Hello and welcome back. Let's continue to look at functions and their limits. So here we're given a function x squared minus 1 divided by x plus 1. Now when we look at this, we are being asked to find the limit as x approaches negative 1 from the left and the right. And one thing that you may be tempted to do is to just think, oh, this function is going to be doing something. I don't know what it's going to be doing. So let's just plug in negative 1 and see what the value is at negative 1. Well, let's just try this. What is f of negative 1? Well, on the top, we get negative 1 squared minus 1. On the bottom, we get negative 1 plus 1. So negative 1 squared minus 1, that's 0. Negative 1 plus 1, well, that's 0. We can't divide by 0. So in fact, f of negative 1 does not exist. So whatever the function is doing at negative 1, I can't even plug in negative 1. This function doesn't even exist at negative 1. So what I've done down here is, before I graph this and before I show you sort of a picture of what exactly is going on, let's do this numerically. If I approach negative 1 from the left, I have to use numbers that are slightly more negative than negative 1. So maybe I'll plug in negative 1.1. And I get negative 2.1. If I plug in a number that's a little bit closer to negative 1, I get negative 2.01. Plug in a number that's even closer, negative 2.001. Now, this isn't a proof. This isn't exact. I could get a lot closer. Maybe this function does some weird things. But it really feels like, as we approach negative 1 from the left-hand side, it really feels like this is getting close to negative 2. If I look at this from the right-hand side, so from the right-hand side of negative 1, so a slightly more positive number than negative 1 might be negative 0.9 or 0.99, 0.999. As I plug these in, I'm still getting close to negative 2. Negative 1.9, negative 1.99, negative 1.999. So all these seem to be getting close to negative 2 as well. So let's actually graph this guy and see what's going on. And in order to graph him, what I'll do is, let's simplify this. X squared minus 1. I can factor this into x plus 1 times x minus 1. And I have a factor of x plus 1 on top. I have a factor of x plus 1 on the bottom. I get x minus 1. Now, I still can't plug negative 1 into this function because this was the function. This isn't. This is sort of the simplified one. But even if this is simplified, if I plug in any number that's not negative 1, I can plug it into here. So this function actually looks exactly like x is equal to negative 1, x minus 1. That was silly of me. So our slope is 1, and our y-intercept is negative 1. So y-intercept is negative 1, slope is 1. So our function looks something like this. Except I can't plug negative 1 in. So what happens is, as I come down, I have to draw an open circle there. Let me make that a little bit better. Oops. I have this open circle here, and as I approach negative 1 from the left or the right, say as x gets closer and closer to negative 1, along my function I go, and I'm getting closer and closer to negative 2. If I approach negative 1, oh, this is from the left, the other was from the right, excuse me, I will approach negative 2 again. But my function doesn't exist there, as in I can't plug in negative 1 into my function. And you know what? It doesn't matter. As we approach negative 1, x equals negative 1, from the left, we're still getting closer and closer to negative 2. As we approach negative 1 from the right, my function height is still getting closer and closer to negative 2. So this limit exists and is negative 2, even though my function does not exist there. So this is a common trick we can simplify our fractions, just keeping in mind that this is the function itself. And I can clearly see that -1 is not in the domain of this function. I can't plug -1 in. Even though I can simplify it, I can't plug -1 in. But it doesn't matter for the limit. It doesn't matter what the function equals there, as long as we can get close to it from the left and right. Let's look at another situation here. We have f of x is equal to 1 over x. And this is quite a nice function. It looks something like this. And we can see that at 0, we're doing something weird. So we can plug in some values. So as we approach 0 from the left-hand side, if I plug in some numbers that are slightly more negative than 0, say -0.1, -0.01, -0.001, well, I'm just taking 1 and I'm dividing by that. So 1 divided by -1/10 is -10. 1 divided by -100th is -100. 1 divided by -1000th is -1000. So as x approaches 0 from the left-hand side, what happens to my function height? We're going down. And in fact, we're never going to stop going down. And no matter what number you ever give me, like maybe here, maybe this is my y value, we can find a place where the x value that we plug in will get us below that. No matter what number you give me, this is going to continue going down, and not only is it going to continue going down, it's going to get lower than any number you could ever think of. So the way that we write this down, as x approaches 0 from the left-hand side, our function height is approaching -infinity. This is where we get to use infinity, even though it's not a number in a more traditional sense. This has meaning. So as x approaches 0 from the left-hand side, f of x is approaching -infinity. If we look from the right-hand side, as we plug in x's that are closer and closer to 0 from the right-hand side, so say 0.1, 0.01, 0.001, our function height is increasing. The reciprocal of 1/10 is 10. Of 1/100th is 100. 1,000, 10,000. We can keep going as far as we want. Million, billion, quadrillion. We can keep going up and up and up and up. So as we approach 0 from that right-hand side, our function is increasing without bound, meaning that there is no cap. No matter what number you give me, the function height is going to get bigger than that eventually. No matter how high, how big of a number you give me, will always get bigger. So on this side, our function is going to positive infinity. It's going up. And this limit here does not exist. And again, why does the limit not exist? Well, the limits are different on both sides. One is going down forever, going to negative infinity. One is going up forever to positive infinity. Those aren't the same. We don't consider those the same thing. So this limit does not exist. And just to clarify what these mean, we can say that a limit equals infinity, even though it's not a number, when the function increases without bound. And again, when I say a bound, I mean there's no cap. There's no limit for how big this can get. Although I shouldn't use the word limit like that. So this function will increase, and we cannot. There's no boundary to it. It's gonna go through every number that we can ever think of. And likewise, the same with negative infinity. A limit equals negative infinity when the function decreases without bound. So limits can be negative infinity, infinity, and let's look at another sort of way that we can invoke infinity in here. So let me draw our function again. So our function is going to look something like this. So as x approaches 0, we were getting close to infinity if we're coming from the right. we're getting close to negative infinity if we're approaching from the left. But here's infinity showing up in a new place. We can let x approach infinity as well. And again, infinity isn't really a number. So what does it mean to approach infinity? It means to get big, and again, without bound. There's no cap. We're going to get bigger than any number that you can ever think of. So as we plug in bigger and bigger values for x, as we approach infinity, so infinity is going to be way over to the right. In fact, infinitely far to the right, hence it's in the name. We can see that as we get further and further to the right, what happens to our function value? It's kind of going down. And it's getting closer and closer to the x-axis, which represent a height of 0. And we can think about this sort of numerically as well. If I take 1 divided by 10 versus 1 divided by 100 versus 1 divided by 1,000, if I keep getting bigger and bigger and bigger, these numbers are getting smaller and smaller. Not smaller as in more and more negative, but smaller as in closer and closer to 0. So this limit is in fact going to be 0. As I follow this function to the right, our function height is getting closer and closer to 0. Again, we can go, instead of going to infinity, we can go to negative infinity, meaning that we're getting further and further to the left. And again, our function height, as we follow our function height, is getting closer and closer to 0. So again, if I take 1 divided by negative 10, 1 divided by negative 100, negative 1,000, negative 10,000, as we go further and further to the left, our function height is getting closer and closer to 0. When we have limits as x approaches infinity or as x approaches negative infinity, we just follow our function as it goes further and further to the right or to the left. One quick aside, which is going to seem a little bit silly, but worth mentioning. Could I talk about limits as x approaches infinity from the left or from the right? Well, if we think infinity is basically as far right as you can ever go, it's further to the right than any number. So I can only approach it from the left. I can only come at it from the left-hand side. There's no way that I can start out here and come this way to infinity. No, infinity's further to the right than that. I can't get on the other side. So we don't normally talk about approaching infinity from the left or right. It just doesn't really make any sense. It's too far out there.